Good afternoon, everyone. Yep. Welcome to the fourth tutorial of this course. So, in this tutorial, I will be solving assignment 4 from last year's course. And if you at any moment if you face some problems of understanding what I'm doing, then you can unmute and ask, or you can write in the comment section. Let me share my screen. So, I have shared the screen. Hope it's visible. If the screen is not visible, please let me know. Okay, the first problem is the value of the local minimum of the function f of xy equals to x square minus xy plus y square plus 2x plus 2y minus 4 is. So we have to find out the local minimum of this function. So for that we first need to find out what are the critical points we have for this function. So it has two independent variables. The critical points we have for critical points, if we are at the critical points, then del f del x will be 0 and del f del y will be 0. So with this condition we will find all the critical points we have for this function. So if you do del f del x, then it will be del x of this whole function, del x of this is x square minus xy plus y square plus 2x plus 2y minus 4 equals to 0. This implies so if you do del x of the first term, it will be 2x minus minus y and del x of first and the third term is 0, the fourth term is plus 2 and the other terms will be 0. So from this relation I can write y equals to 2x plus 1, 2x plus 2. So equation 1, and now we will use this del f del y equals to 0. So del f del y equals to 0. So if we do del y of this function, it will be the first term del y of x square is 0, then the second term is minus x, the third term will be plus 2y, fourth term is 0, the fifth term is 2 and the sixth one is 0. So now x equals to 2y plus 2. So all the critical points of this function will satisfy this equation 1 and equation 2. So if I put this, we have two equations and two unknowns x and y. So put the value of x, we found put the expression of x from equation 2 in 1. So it will be y equals to 2 times 2y plus 2 plus 2. So it will be 4y plus 6. and now if I put this value in equation 2, it will, then the value of x will be sorry, I just can find the value of y from here. The value of y will be minus 3y equals to 6 to imply y equals to minus 2. And if I put the value of y in this equation 2, it will be x equals to 2 times minus 2 plus 2, which is minus 4 plus 2, and that is minus 2. So the critical point is critical point is minus 2 minus 2. So now we need to check whether that point is a maxima of whether that point is a local minimum of this function. So for that we need to find the discriminant at this critical point. So the discriminant is defined as AC minus B square, where A is half del 2f del x2, C is half del 2f del y2, and B is half del 2f del y del x. So then A will be half of del x of del f del x. Now del f del x we already calculated here. Del f del x, so del f del x is 2x minus y plus 2. 2x minus y plus 2. Then the del x of this quantity will be only 2, and then there is 1 by 2, so A is 1. So now we can calculate the C will be half of del y of del f del y, and del f del y we calculated here. Yeah, it is minus x plus 2y plus 2. Minus x plus 2y plus 2. And del y of this term will be only 2, and there is a half here, so C is also 1, and if you calculate B, it will be half of del y of this del f del x, and that is 2x minus y plus 2, which will be minus half. So the discriminant, the value of this discriminant D it will be AC minus B square so AC is 1 and AC is 1 and minus 1 by 4 is 3 by 4, which is greater than 0. So that means it greater than 0 means this critical point is not a saddle point, and we also have a greater than 0. So we have this discriminant greater than 0 and a greater than 0 is 1. So the point is a minimum, it's a local minimum. And then at this local minima, the value of this function will be, just put the value of this, put the points, so f of x y, x equals to minus 2, y equals to minus 2, it will be x square, so x square is 4 minus x square minus xy plus y square. Okay. So then xy is 4, so minus xy is minus 4, then plus y square is 4 plus 2x will be, then x is minus 2, so minus 4 plus 2y will be again minus 4, and there is minus 4. So then this 4 cancels with this one, plus 4 cancels with this one, so it's minus 8. So at this point where the function is at its local minima, its value, the functional value is minus 8. So the correct answer is this one. So now the second problem. Okay, in this problem we are asked to find out the local maxima, the value of the local maxima of this function. So we will solve it similarly. First we will find out what are the critical points. So find out the critical points. The critical points we will solve del f del x equals to 0. So if we do del f del x of this function, it will be, so del x of this function, so it will be 6x square plus 3y equals to 0, which will give y equals to minus 2x square, and to get critical points, then another equation we need to satisfy, that is del f del y equals to 0, and it will give 3x plus 6y square, 3x plus 6y square. So from there, write x equals to minus 2y square. So now if we put this value of y, call it equation 1 and equation 2. So now if I put this value of y in equation 2, it will be x equals to minus 2 of minus 2x square whole square. So then it will be minus 8 x to the power 4. So now if I take this in the left hand side, it will be x plus 8 x to the power 4 equals to 0. So now if I take 8x common, it will be x cube plus 1 by 8 equals to 0, which gives me x equals to 0 and x cube equals to minus 1 by 8, and we are only interested in the real solutions of x, so then x will be minus 1 by 2. And now when x equals to 0, the value of y we can find from equation 1, y is also 0, and when x equals to minus half, y equals to, so if I put minus half in equation 1, then it is, so x square is 1 by 4 and there is a 2 here, so if you multiply by 2 it is half and there is a minus sign, so y is also minus half. So the two critical points are 0 0 and minus half minus half. So these are the two critical points. So now we need to find out where it is maxima, whether these critical points are local maxima, local minima, or saddle points. Okay, so for that we need to calculate the discriminant. T is AC minus B square, where A is half of del x of del f del x, and del f del x is 6x square plus 3y. So it is 6x square plus 3y, which is so del x of this whole quantity will be 12x, and there is a half here, so it will be 6x. C will be half of del y of del f del y, and del f del y is 3x plus 6y square. So it is 3x plus 6y square, and then if we do del y of this term, it will be 12y, and that is half, so it becomes 6y, and the b will be half of del y of del f del x, and del f del x is 6x square plus 3y, and if we do the del y of it, it will be 3 only, and there is a half here, so it is 3 by 2. Okay, so the value of this discriminant is AC minus B square, so that is 36 xy minus 9 by 4. Okay, and now for this critical point 0 0, so d for x equals to 0, y equals to 0, it is only minus 9 by 4, and it is negative, is less than 0. So this 0 0 point is a saddle point. This is a saddle point, and for the other point minus half, so d at x equals to minus half, y equals to minus half will be 36 times 1 by 4 minus 9 by 4. So it will be 4, and this is 36 minus 9, which is obviously greater than 0. So we have something here, either local maximum or local minima, and so for that, whether it is local maximum or minimum, we check what's the value of A at this point. So value of A at x equals to minus half, y equals to minus half, it equals to minus 6 by 2. A is 6x, so it will be minus 6 by 2, that is minus 3, which is less than 0. So at this point minus half, d is greater than 0 and a is less than 0. So it means we have a local maxima at this minus of point, and if you put the value of this point in this function, we will get the value of this local maximum. So the functional value of this local maxima will be x equals to minus of, y equals to minus of, and this is 2x cube, so it is 2 times minus 1 by 8 plus 3xy plus 2y cube. 3xy, xy means 1 by 4, and plus 2 times y cube is again minus 1 by 8. So it is minus 1 by 4 plus 3 by 4 minus another 1 by 4. So 2 3 by 4 if we subtract from 3 by 4, from 3 by 4 if we subtract, this is 3 by 4 minus 1, that is 1 by 4. So minus of is the local maxima and the functional value at this point is 1 by 4. So 1 by 4 is the value of the local maximum of this function. So the third option is the correct one. These problems are a little bit lengthy. Okay, so we are again given a function f of xy, that is x cube plus y cube plus 3x square minus 3y square, and we are asked to find out the saddle point. Okay, so first of all we have to find out the critical points. Same process, del f del x equals to 0, and if we do that, so you might be feeling bored, for that I will suggest you do it parallelly. So del f del x will be 3x square plus 6x equals to 0, which implies if we take 3x common, it will be x plus 2 equals to 0. This implies x equals to 0 and minus 2. So it doesn't depend on whether the value of y. At x equals to 0 and minus 2, the del f del x will be 0. And now for the other condition, del f del y equals to 0, we have so del f del y of this first term is 0, the second term is 3y square, this is 3y square, the third term is 0, and the fourth term is minus 6y equals to 0. It implies 3y, if I take common, this is y minus 2 equals to 0, and then it is y equals to 0 and 2. So the critical points are, so we have 4 critical points. So critical points will be 0 0, that's what 0 0, del f del x will be 0, del f del y will be 0. It can be 0 2, it can be minus 2 0, and it can be minus 2 2. So we have 4 critical points here. Okay, so now for each of these critical points we need to check. Okay, in the options we have 0 0, and these critical points in the option we don't have. So first we will check whether 0 0 is a saddle point or not. If 0 0 is a saddle point, then we are done. So first we will check for 0 0. So for that we need to calculate the discriminant d, which is ac minus b square, where a will be half of del x of del f del x, and del f del x is 3x square plus 6x. So it is 3x square plus 6x, which will be half of 6x plus 6, which is 3x plus 3. C will be half of del y of del f del y. Del f del y is 3y square minus 6y. So this is 3y square minus 6y, which will be, so this is 6, again this is 3y minus 3. And b will be half of del x of del f del y. Now del f del y is only a function of y, so if you do del x of that, it will be 0. It doesn't depend on x and y. In that case, now if I put the points, so we want to find whether there is a saddle point or maxima minima at this point 0 0. So in that case, the discriminant at this point 0 0, it will be AC minus B, and B is 0, so it is 3x plus 3x plus 3 times 3y minus 3 at point 0 0. And if I put the value at point 0 0, then it will be minus 9, which is less than 0. So the discriminant less than 0, that means we have a saddle point. So the 0 0 is the saddle point. And you can check yourself whether these points are saddle points or not, whether these are local, some of these will be local maximum minimum. So you can check for that in this same method. Okay, so now we are asked to maximize this function f of xy equals to 49 minus x square minus y square on this line. So this is a constraint maximization. The constraint is this 3x x plus 3y equals to 0. So one easy way to do that is just replace this value. So you can find the value of x from this equation, that will be 10 minus 3y, and put it in f of xy, so you will get a function of f of x and then do the maximization. But since we are introduced with Lagrange method, we will solve it from the Lagrange method. So the method is basically so at this maxima under this constraint, it will satisfy these equations. So let me call it C, which is f is this one. F of xy is 49 minus x square minus y square, and calling this equation of this line, this constraint, as G. Constraint is x plus 3y minus 10 and is equals to 0. So now for this constraint maximization, it will satisfy at the point of maximum or minimum, it will satisfy these conditions. Gradient of f equals to lambda of gradient of g, and this lambda is the Lagrange undetermined constant. So if we take grad of f, then it will be, so this del x of f comma, it's a two variable function, so there will be two components, and del y of f, and this is lambda times del g del x comma del g del y. So if we do del f del x, then it is minus 2x comma, if we do del f del y, then it will be minus 2y equals to lambda times del g del x. Del g del x is 1, and del g del y will be 3. So we have two equations from this relation. These equations are minus 2x equals to lambda for the first component, if we compare the first component, and the second equation will be minus 2y equals to 3 lambda. So we have three unknown, that is lambda, x and y, and here we have three equations, and another equation will be this constant equation. So we have total 3 equations, and we need to find out the value of this x and y. Okay, so for that, from here we will put we calculate the value of x, it will be minus lambda by 2, and from here calculate the value of y, it will be minus 3 by 2 lambda. And if I put these values in this constant equation is x plus 3y minus 10, 3y minus 10 equals to 0, and if I put these values, it will be minus lambda by 2, minus 9 by 2 lambda equals to 10, so it will be minus 10 by 2 times lambda equals to 10, so our lambda will be minus 2. And now if I put this value of lambda in this, let me call it equation 2 and 3, and this constant equation is equation 1. So now if I put the value of lambda in equation 2 and 3, we will get the point where this function has a maximum value. So then x will be minus lambda by 2, and lambda is minus 2, so it will be minus of minus 2 by 2, it will be 1, and y will be minus 3 by 2 times lambda, minus 3 by 2 times minus 2, which will be 3. So at point 1, 3, this function will take its maximum value while being on this line x plus 3y equals to 10, and we need to find out the maximum value, so we will put the points in this function. So f of x equals to, so f at x equals to 1, y equals to 3, functional value will be, so it will be 49 minus 1 square minus 3 square. 49 minus 1 square is 1, minus 3 minus 3 square is 9, so this 49 minus 10, that is 39. So the maximum value will be 39, maximum value of this function while being on this line x plus 3y equals to 10. If you have any confusions of understanding how I am applying this Lagrange multiplier method, then you can ask me, you can comment, or you can ask. So again, here we are asked to find out the point on this plane. So this is a kind of constant here, we should be on this plane, x plus 2y plus 3z equals to 13, and we are asked to find out what will be the closest point to 1, 1, 1. So let's assume the closest point will be x, y and z. So in that case, its distance from 1, 1, 1 will be, we call it d, which is the function of x, y, z, is root under x minus 1 whole square plus y minus 1 whole square plus z minus 1 whole square. So this is the distance. So this is the distance of any point xyz from point 1, 1, 1, and we need to get closest to this 1, 1, 1 point. So we need to minimize this distance. So now minimizing d is same as minimizing d square. Why we are doing d square? Because there is a root, and if you do derivatives and all, it will be complicated. So instead of minimizing d, we will minimize d square, because it's anyway d is a positive quantity. So d square is y minus 1 whole square plus So we are minimizing d square because if we want to minimize d, there is a root under sign, there is a root, and it will be difficult to calculate that del d del x and all these things, all the derivatives. So we will call f of x y z as d square. So f of x y z as d square is the square of this distance, and we will minimize that. Minimizing that is same as minimizing the distance, and the constant will be this. So we need to be on this plane. So I am writing the equation of the plane as g of x y z equals to x plus 2y plus 3z, x plus 2y plus 3z, minus 13 I am writing on this side, so minus 13 and right hand side I am putting 0. So now let me call this as equation 1. So now for optimization, the condition is grad f equals to lambda times grad of g. So now it's a 3 variable function, so we will have 3 components. So if we do grad of f, it will be, the first component will be del f del x. So del f del x, right, then the second component will be del f del y, and the z component will be del f del z, equals to, similarly for grad of g, the x component will be del g del x, y component will be del g del y, and the z component will be del g del z. Now del f del x is twice x minus 1, so it is twice x minus 1. Del f del y will be twice y minus 1, and del f del z will be twice z minus 1. And the right hand side will be lambda times del g del x. Del g del x is 1 because only this term will survive, first term, so it is 1. Now del g del y will be 2, and del g del z is 3. So here we have 3 equations. So that is, if we compare the first components, it will be twice x minus 1 equals to lambda. So from here we can write x equals to lambda by 2 plus 1. Okay, let me call it equation 2. And comparing the second components, we have twice y minus 1 equals to 2 lambda. From here we have y equals to, these 2 cancels, and y equals to lambda plus 1. Let me call it equation 3, and comparing the last component, it will be 2z minus 1 equals to 3 lambda. 2z minus 1 equals to 3 lambda. So then z equals to 3 by 2 lambda plus 1. So this will be the fourth equation. So we have 4 unknowns, that is lambda and xyz, and we have these 4 equations, these 3 equations and this constant equation. So we have to be on this plane. And now if we put this value of xyz in this constant equation, we will get the value of lambda. So let's put the values. So x plus 2y plus 3z. So x is lambda by 2 plus 1, lambda by 2 plus 1 plus 2y, that is 2 lambda plus 2 plus 3z, right, plus 3z. So 3z will be 9 by 2 lambda plus 3 equals to 13. Yes. So now if we calculate, is 2, 1 plus 4 plus 9 times lambda equals to 13 minus 3 minus 2 minus 1. 13 minus 3 is 10 and minus 3 is 7. This side it will be 14 by 2 is again 7 lambda. This implies lambda equals to 1. And now if I put the value of lambda in equation 2, 3 and 4, we will get the value of x, y and z. So if I put these values, then x will be lambda by 2 plus 1 and lambda is 1. So this is half plus 1, that is 3 by 2. Y will be lambda plus 1, lambda is 1, so y will be 2, and z will be 3 by 2 lambda plus 1, so that is 3 by 2 plus 1, which will be 5 by 2. So this is the point. So the point will be 3 by 2 to 5 by 2. So this is the point where the distance from this point 1, 1, 1 is minimum, and it is the point is also on this plane x plus 2y plus 3z equals to 13. So the correct answer is this one, 3 by 2, 2 and 5 by 2. This is the constraint minimization. So now problem 6. So we are asked to find out the points on this curve xy square equals to 54 nearest to the origin. So let me assume that any point is xy. So we are in 2D here. So we have to be on this 2D curve xy square equals to 54. So this is the constraint we have. And if we assume that any point on two dimension is xy, so then the distance from the origin will be d equals to root under x square plus y square, and we need to minimize this distance. We need to get nearest to the origin, and while being on this curve xy square equals to 54, so the constraint is equal g of xy, that will be xy square minus 54 equals to 0. Xy square minus 54 equals to 0. This is the constraint. We call it equation 1. So being on this curve, we need to get closest to the origin. So we need to minimize d. But same as here, to minimize, we need to do the derivatives. So we need to do del x, del y, these kind of things. And so having a root will be problematic. So we will, instead of minimizing d, we will be minimizing d square. So let's define f of xy that we will minimize, which is d square, that is x square plus y square. And now if we apply this Lagrange method, it will be, the equation will be gradient of f xy equals to lambda grad of g x. Okay, one point is, one thing to note is, you can take lambda like, so you can, it's kind of an arbitrary undetermined constant. So in some case you will find solving lambda as this one, like taking the minus lambda. So it doesn't depend on whether the lambda you are taking positive or negative, because anyway at the end we don't need lambda. So I will do in this way, just putting lambda on the right hand side. So the x component will be del f del x, and the y component will be del f del y equals to lambda times del g del x comma del g del y, and del f del x is 2x comma del f del y will be 2y equals to lambda times, so del g del x is y square, so this is g x y square minus 54, del g del x y square and del g del y, so we take x as constant and do derivative with respect to y, so it will be 2xy. So the equations we have are 2x equals to lambda y square and 2y equals to lambda times 2xy. Call it equation 2, and this equation we can further simplify. It's 2 will cancel, and okay, so we can cancel y, but before that we have to make sure y not equals to 0. So if we look at this constant equation, so while minimizing this f, we should always be on this curve xy square equals to 54, and this curve doesn't allow y equals to 4 point, oh, sorry, y equals to 0 point, because if we put y equals to 0, this 54 will be 0 and this is not valid. So basically this curve doesn't pass through such points where y equals to 0, so we can cancel y because y not is equals to 0, and we are left with x equals to lambda. So if x equals to lambda, then so let me call it equation 3. So then this x value, if I put sorry, x equals to 1 by lambda, so this x lambda equals to 1, so x equals to 1 by, so now x equals to 1 by lambda, if I put equation 2, then it will be, so it will be y square lambda equals to 2 times 1 by lambda, and y square equals to 2 by lambda square. So let me call it equation 4. So we have x equals to 1 by lambda and y square equals to 2 by lambda square. And now if I put this value of x and y in equation 1, so in equation 1 we have x y square equals to 54, right? X y square equals to 54, and now if I replace these values, that y square equals to 2 by lambda square and x equals to 1 by lambda, so it will be 1 by lambda times 2 by lambda square equals to 54, and then it will be 1 by lambda cube equals to 54 by 2, and 54 by 2 is 27. In that case 1 by lambda is 3 and lambda is, and lambda is 1 by 3. Okay, so we got the lambda, this is the Lagrange undetermined constant, and if you put the value here in equation 3 and 4, we will get the points x and y. So we put the values here, it will be x equals to lambda 1 by lambda, so x equals to 1 by lambda means x equals to 3, and y square equals to 2 by lambda square, which means 3 square times 2, then y will be plus minus 3. Okay, so the points will be, so x equals to 2 and x equals to 3 and y equals to plus minus 3 root 2, 3 comma 3 root 2, this will be one point and another point will be 3 comma minus 3. These are the 2 points uh, from which the origin is the nearest, and we are still on this curve, so we are still satisfying this constant. So the correct option is 3 and plus minus 3 root 2. 3 and plus minus 3 root 2, second one. Okay. Now the seventh problem. This it's a very easy problem. So we're also this position vector are given a r as a function of t, which is t plus 1 I cap plus t square minus 1 j cap. We have to find out the velocity and the acceleration. So v will be dr dt, which will be, if we took the ddt of this t plus 1, it is I cap only, and if we look the ddt of the second one, it will be t j cap, and a will be dv dt, and if we took ddt of this constant, this I hat, so it will be 0, and only j component will survive, so it will be 2 j cap. Okay, now at t equals to 1, at t equals to 1, v will be, at t equals to 1, it will be I cap plus 2 j cap, and at t equals to 1, a is always constant, so it doesn't depend on t, so it will be 2 j cap. So it is I cap plus 2 j cap, and second one. The next problem is we have to find out the unit tangent vector of this curve. Okay, so the curve is changing with t. So this is the curve. This is the r vector as a function of t, which is given. So this is the origin. So the tangent direction will be the direction of velocity, that is r dot. So call it v t, which is dr dt. So why this velocity direction is the tangent direction, that already shown in the class, so I will not prove that again. Now dr dt will be ddt of, so r has its 3 components, 2 cos t, 2 sin t, and root 5 t. 2 cos t, comma 2 sin t, comma root 5 t. The ddt, there will be minus 2 sin t, comma 2 cos t, and root 5. This is a vector along this along this tangential direction, and we need to find out the unit tangent vector. So that means we need to find out the unit vector along this direction. So we call it v cap, which will be vt by mod of v, and mod of v will be minus 2 sin t, sorry, v will be already calculated, cos t root 5, and mod of v will be root under x component square, that is 4 sin square t, plus y component square, y component is 2 cos t, so it will be 4 cos square t, and plus z component square, that is 5. So it will be, so this term will be, sine square t plus cos square t 1, so this is root 9, that is 3. So the unit vector will be minus 3 by 2 sine t I cap plus 2 by 3 cos t j cap plus root 5 by 3 k cap. So correct answer will be minus 3 by 2 sine minus 3 by minus 2 by minus 2 by 3 sine t. So minus 2 by 3, the first option is the correct one. Yes. And the next problem is we have to find out the length of this curve. So this is the equation of this curve. So RT, which is cos cube t I cap plus sine cube t j cap. And so this curve is already parameterized. So as it's a curve, it is only one parameter thing. So as we change t, so for example, let's say we have a curve, and this is the position r vector, this is the origin, and it's a function of t. T is the parameter. So now if we change t, then we will move along this curve, and we have to find out the length of this curve when from t equals to 0 to t equals to pi by 4. Okay, so for example, let's say at this point where t is equals to 0, and at this point t equals to pi by 4, sorry, pi by 2. And we have to find out the length. So now to find out the length, we need to get a infinitesimal distance along this curve at any point of t. So let's call it dr, which is a function of t. So this is at any point t, this is the infinitesimal length on this curve, and the whole length will be then integration of dr, integration of this dr from t equals to 0 to t equals to pi by 2. So for each t we will get this dr, for each t we will get dr, and we will sum it up. So integration, sorry, it's a magnitude. So this length we will just sum it up and we will get the total length of this curve. Okay. So now we need to find out this dr. So the r is basically cos cube t I cap plus sine cube t j cap. So in that case, dr vector will be r dot times dt. What does the dr signify? Dr signifies if we do an infinitesimal change in t, that is dt, what will be the change of di? And the rate of change of r is r dot. So basically r dot is the rate of change of r with t, and now if we multiply it with the change in t, we will get the change in r. So the dr will be then r dot is 3 cos square t, there is minus sign, sine t I cap plus 3 sine square t cos t j cap. So times dt. So this dr vector will be 3 sine t cos t. If I take common, then it will be minus cos t I cap plus sin t j cap times dt. So the magnitude of this length will be, this length element will be root under root under sorry root under 3 sin t cos t whole square times x component square, so it is cos square t plus sin square t times dt square. So this is the length, this is the infinitesimal length dr at any value of t. So if I do the calculation, it will be 3 sin t cos t dt, because this value is 1, which is, I can write is like 3 cos t d of sin t. This d of sin t is sin t dt, and to find out the whole length we need to add up all these drs. So basically we need to do the integration. So L will be integration dr, which is integration 3 cos t d of sin t, sorry, there is a sin t. So this cos t dt I am writing as d of sin t. D of sin t is cos t dt. From t equals to 0 to pi by 2. Now if we do the calculation, it will be sin square t by 2 from t equals to 0 to pi by 2. So now it is 3 by 2, and if we put the upper limit, the sin square t is 1, and for lower limit it is 0. So the length is 3 by 2. So the correct option is this one. And again we have a similar problem. We are asked to find out the length of this curve, and the curve is given as rt equals to root 2 into t I cap plus root 2 into t j cap plus 1 minus t square k cap, and the limiter. So for example, if this is the curve, so then from point 0 0 1 to point root 2 0, we are asked to find out the length. Okay, so here r is already parameterized, the equation of the curve is already parameterized, so the parameter is t. So for each value of t we will be at some point on this curve, so change t and we will move along this curve. And so to start with this point, there will be a value of t for which we will be at this point, and you can easily see that if I put t equals to 0, then the r will be this one, the 0 0 1, right? So if I put t equals to 0, then r will be only k cap, that means we are at this point. And if you put t equals to 1, then we will be at root 2 and 0 point. So basically this 0 0 1 point corresponds to t equals to 0. If I replace this xyz values with the parameter value, and for t equals to 1, we are at this point. Okay, so similarly we will calculate this dr, this infinitesimal length, and we will do the integration. So the vector dr will be just r dot dt, which is due to the r dot, it will be root 2 I cap, root 2 I cap plus root 2 j cap plus sorry, there will be minus, so minus 2t k cap times dt. Okay, then the infinitesimal length, so dr will be absolute of that, dr will be mod of dr vector, which is root under x component square is 2 plus y component square is 2 plus z component square is 4t square times dt. So if we do this addition, it will be 4, and if I take 4 outside, 2 times 1 plus t square dt. So this is the infinitesimal length, and we will just add it up. So the total length will be integration dr from t equals to 0 to 1. If we go from t equals to 0 to 1, we will just go from this 0, 0, 1 to root 2 to 0 point. Now this is root under 1 plus t square dt, t equals to 0 to 1, and this is a standard integration, so the integration value I wrote it down. It is ln of mod of root under 1 plus t square plus t plus t times root under t square plus 1, and from t equals to 0 to 1. Now if I put the upper limit, it will be, if I put the upper limit, it will be root 2, so this will be root 2 and this is 1, so for upper limit it is ln mod of root 2 plus 1, and the other term will be, so this is 1, t is 1, and this is root 2, so this is plus root 2 and minus the lower limit. Now if you put the lower limit, then this will be log of 1, so if I put t equals to 0, this is 0, this is 0, so we are left with log of 1, log of 1 is 0, and again if I put 0 here, so this term is 0 and then the whole term will be 0. So the lower limit, if I put the lower limit, that term will be 0. So okay, in that integration formula there is a half. So the integration of this root under 1 plus t square is ln of this plus t times root under t square plus 2 by 2. So there is a half here. So this half will cancel each other, and we are left with ln 2 plus 1. So this will be the length of this curve from this point to this point. So the correct option is second one. Okay, so these were the 10 problems from last year's assignment 4. If you have any confusions regarding the solutions or any problem regarding the lecture videos, you can unmute and ask, or you can write in the comment section. Okay, if not, then you can leave one by one, so I'll be ending the class.